So now we finalized session 1 and move to session 2. I welcome Javier Alcodori Ramos. Javier, he's holds a degree in biotechnology and a master's in research and development in biotechnology and biomedicine from the University of Valencia. He's a researcher from ITENE. His work focuses on research and assessment of the toxicity and ecotoxicity of nanomaterials, chemicals, and other substances, aiming to develop comprehensive toxicological profiles. He actively contributes to the implementation of the Safe and Sustainable by Design framework, an initiative led by the European Commission to promote the responsible development of materials and products. Additionally, he is engaged in the development of innovative solutions with antimicrobial, antifungal, and virucidal properties, including advanced paints and disinfectants. So welcome. Thank you for accepting the invitation. I'm just going to let me know which one. Okay. So this is not working. Please use this one. Okay. Okay. Thank you. So thank you all for being here. And I ask you for organizing the meeting with RDC and also Thessaloniki for being the coordinators of Redondo. I'm Javier Alcodori, and as Carla said, I work in ITENE in the safety of processes and products unit. And I'm going to explain how are we applying the Safe and Sustainable Design framework in polymeric materials in Redondo project. So I will do a brief introduction of how is the Redondo project. It has been already introduced, but then how we are implementing the Safe and Sustainable Design methodology. And finally, I will conclude with some remarks. So in this case, Redondo aims to propose an alternative for polyethylene reticulate that is the recyclable, safe, and sustainable by design for pipes and for cables, as has already been explained. In the case of the Safe and Sustainable by Design methodology, this is an initiative that later on evolved in a framework that was developed by the European Commission in order to minimize at an early phase the effects that the developments, the chemicals, and the materials that could be interfering with human health and also with environmental health. Through this, we address the safety and sustainability of the materials, chemicals, and products along all the life cycle, including production, use, disposal, and the research and development phase. So the framework is composed by 5 different steps. The main 3 first steps are dedicated to safety, and then the 2 last steps are dedicated to sustainability, and this will be addressed also in another talk by Elena. In the first step, we are assessing the hazardous properties of the chemicals and the materials that we are using to develop the new product, and also how this product will be in terms of hazardous properties. Then the second step will cover how the production and the processing of this new material or new product that we are developing may affect to the health of workers and also the environment. And then in the third step, we will assess how this product may affect the final consumer, the one that are going to be using this product. Then in the first step, there will be an environmental sustainability assessment. And then in the fifth step, the social and the economical assessment. With all these steps, we are then developing a scoring system that will allow us to take decisions about how are we going to proceed with the design and the redesign phase. This allows us to know if a decision is better in terms of safety and sustainability or it is worse than other. So how are we implementing the step? In the first step, we need to identify three main impacts: human health hazards, environmental health hazards, and then the physical hazard. So the first thing we do is we identify the chemical that is being used or we want to use, and we assess this chemical in the regulations regarding REACH and CLP mainly. If we find here information, we apply it to our matrix, and then we see where are we missing some data. If we need more data, we gather information from other sources like bibliography, computational models, or experimental data that is available. We also assess the chemical in particular that is being used in the product, because sometimes, depending on the supplier, the hazardous properties of a chemical may differ because of the, for example, purification phase that they are using. Then we analyze all this gap, all the data gap that we have identified, and then we go back in order to solve these gaps that we identified. If we cannot solve these gaps, then we proceed with the experimental assays regarding three main endpoints here, which are cytotoxicity, genotoxicity, and then inflammation. When we have all the information, we propose some actions that we take with the developers of the product, and then we reassess again all the new development or the new design that we are doing. So in the second step, then we assess the human health and safety aspects of production and processing. It has been now also applied that environmental impacts should be taken into account in this phase. So we do exactly the same. With the data that we gathered in the first step, we assess the chemical and we process with a risk classification. Here, it is also important that we know how are the workers operating in the industry. How are the risk management measures that are being taken? With this, we perform an analysis of the risks and we plan some actions depending on the area of exposure to the hazardous chemicals and also the time and the quantity that they are exposed to. And for the final step, the third step regarding safety, we evaluate the migration. We first evaluate the migration of hazardous chemicals from the product that we are developing. So once we have the product, we perform some tests in order to know how much of this product and in a certain way of exposure is being migrating to environment or to human tissues. With this evaluation, we assess how these materials may enter the environment or may enter the human body, and then we take some actions in order to reduce this exposure by, again, redesigning the product. Now, for this first step, these three steps, in these three steps, we need to gather some information. In the REDONDO project, we are focused on gathering information of the human health impact that the materials and chemicals may have. So we decided to use an approach that is based on the exhibition rules, how materials or chemicals may be entering into our body. So we have the inhalation phase, then we are using a cell that is derived from the alveolar wall epithelial. The direct contact, we are using then an epidermal cell line, which is derived by keratinocytes, and then the ingestion cell way of the exhibition, which is why we use the colorectal epithelium cell. Then we perform 3 different endpoints, which are classical endpoints and as a first screening, as a screening are really useful, which is cytotoxicity, in where we are using the MTT assay, which is really a classic toxicological assay. Genotoxicity, we planned to do it by Comet assay, but as you may know, polymeric materials tend to absorb the fluorescent dyes, so we changed to the Western blot, which is also a classical biological technique, and the inflammation, measuring the generation of reactive oxygen species by the cells. So with this approach that I already explained you, this is an example that we got from material used in Redondo. As you can see, first we were in that case, but sorry. Yeah, we were in that case where the viability of the cells was reduced really high, really significantly, even at the lowest concentrations. So we identified that this was a hazardous chemical. We then, with the collaboration of University of Thessaloniki, we decided to change this chemical for another one, and then we got an improvement in terms of cytotoxicity. Then, for the workers' exposure, we have developed a strategy based on 2 different steps, which is first defining the scenarios and assessing them by a software, trying to estimate the exposure and the actions, and then perform some monitoring campaigns that will be performed this coming year. We are using Stoffe Manager, which is a manager for risk management measures that allows us to identify the hazard of the chemical, the possible route, and how is the and determines how is the exposure with data that is gathered from industrial partners, and then give us a risk priority risk in order to take measures. For example, in this project, we had a process that was hazardous, but the exposure was low. Then the software indicated it as a second priority process. If the exposure and the hazard is low, there is a no priority. And for the last step, we are working in the integration migration studies, because we are also finalizing the development of the final product, and we will work with Integra, which is a tool that allows us to model the different migration and exposures. Regarding the step 4 and step 5, this will be explained later on, so I will just go through it not very deeply. What the framework explains is that we need to define a goal, and this work is done by ISQ, by the way, in the project. So there is a need to define a goal and scope, then to perform a cycle inventory, a cycle impact that allow us to know how the impacts of the developments are, and then interpret the results. We gather information from all these different categories, from the production, from the design phase and up to the end of life of the product. Regarding the life cycle costing and the social LCA, this is also done for different categories, also following the same strategy as before. And as a conclusion, the safe and sustainable by design is a tiered approach that allows us to know the risks that these new polymeric materials affect the safety and the sustainability, and allow us to design materials with a reduced impact. The results obtained in the framework implementation will be incorporated in the digital toolbox that is being developed in Redondo, in order to allow a better decision making for formulators and for the industry. And with all the experience that we are gathering from this project, we will develop strategies that are based for specifically polymer sector to move to a greener production and use of these materials. And that's all. So if you have any question?
We'll have time for one question.
At some point you mentioned that in step 2 you are thinking of integrating the environmental aspects
Yes.
as well, but I thought that the environmental aspects were only in steps 4 and 5, so I didn't understand.
Well, what you measure, what you integrate in the second step is, like in the third step, is how the materials and chemicals impact the environment in terms of safety. Which is, for example, if the water from the production is directly put into a river, this will cause some ecotoxicological effects to algae and other aquatic organisms. So you are in these steps, you measure the impact of these effects, while in the sustainability you are measuring all more as a whole.
Thank you very much.
Thank you.